All right, guys, how you doing? This is calibrating and reading lab glassware. So basically, almost like a ruler, but instead of going this way, it's going to go up and down. Okay. So quick math review of quotient or division and units. Okay. So 10 pizzas divided by 5 pizzas. So 10 divided by 5. So how many times can 5 go into 10? And the answer is 2. But then look at the units. You have pizzas over pizzas. So just like math, it'd be like x over x, or 2 over 2. They all cancel out and go to 1. So this answer would just be 2. Okay. Now, let's say we have 10 pizzas divided by 5. There's no unit for the 5, so you can't cancel pizzas out. The answer is still 2, but you have 2 pizzas. Okay. Now, if we change the unit with dollars on the bottom, answer is still 2, but then it's pizzas per dollar. So 2 pizzas, let me get this out of the way, per dollar. So for every $1, you get 2 pizzas. Sounds like a good deal. All right, so just remember the units when you're dividing. They either cancel out, or it has the same units, or you have derived units, meaning that pizzas per dollar is the same thing as how many pizzas you get for $1. Okay, so when your units in the numerator and denominator are the same, they cancel out. Okay, so if you take 6 centimeters divided by 2 centimeters, the centimeters cancel out, and the answer is 3. So basically it's saying that 6 is 3 times bigger than 2. Or 10 dogs divided by 2 dogs is 5. So there's 5 times many. Now, when the unit in the numerator and none in the denominator, unit carries over. So, for example, 8 colas or 8 sodas divided by 4 is just 2 colas. Or 12 Bs divided by 2 is 6 Bs. And then when you have the different units in the numerator and denominator, they carry over, and it's per, or 1 of that denominator. So 8 colas divided by 4 people is 2 colas per person. So every 1 person gets 2 colas. And you have 20 fish per 2 aquariums. That means each aquarium gets 10 fish. Okay, so we talked about calibration before, but quick review. So what does calibration mean? You have to determine what each space on the instrument represents. So what does one space equal on that instrument? So in the ruler, we talked about this previously, each space is 1 millimeter per space, or 0.1 centimeters per space. And what's the general units for calibration? It's always the unit per space. So in most cases, it's either going to be a milliliter per space, or centimeters per space, or millimeters per space. Okay. So you can see in this ruler, each one is 1 millimeter, or 0.1 centimeters. And if you look at the line, we're at 12.645 centimeters. Again, that last number is a guesstimate. All right, so what are the 3 steps of calibrating? So again, you want to make sure you take 2 lines in the instrument that are numbered. So in this example, we take 11 and 10 and subtract the 2. Count the number of spaces between the 2 values. In this case, there's 10. And then you divide the difference between the 2. So we have 1 centimeter, 10 and 11, per 10 spaces is 0.1 centimeter per space, or 1 millimeter per space. Graduated cylinders are just vertical rulers, measure volume. This is always used to measure volume. You always want to use the smallest graduate you can without refilling it. Okay. So if you need to measure 5 milliliters, you use the smallest one possible, which is the 10 milliliter graduated cylinder. Most common ones we have are 10, 25, 50, and 100. We do have 250, 500, and 1000, but the ones that you will use mostly are going to be 5, 25, 50, and 100. Okay, calibration is just like a ruler. Each space is worth a value. Okay, it's in milliliters. So you can see here the big line with the number is 60, and the one below is 50. So the difference is 10. The middle line, just like a ruler, is halfway mark. So that's 55. Meniscus, to read a graduate cylinder, a meniscus, what happens is water cause a concave surface tension. So it kind of adheres to itself and pushes away from the glass. So it makes a meniscus. You always want to read the bottom of the meniscus. Okay, so the liquid and surface curves down. That curvature is called meniscus. And then the meniscus is caused by water sticking to the sides of the glass. And when you read it, you read the bottom of the meniscus. Okay, that gives you a vantage point. So you can see here, it's right here, 8.8 milliliters. Okay, calibration again, same rules. Take two numbers, 60 and 50. Okay, so 10 is the difference, and there's 10 spaces. So each space is 1 millimeter per space. So, for example, it would be 51, 52, 53. Okay, so the meniscus, the bottom of the water line, is between 52 and 53. We're going to say 52.8 because it's closer to the 53 than the 52. Okay, we know it's going to be milliliters. Those are known, so we know it's going to be 52 something. That 0.8 is an estimate. Okay, remember, you always have that little fluctuation of the voice or a little guess at the end. It's like 52.8. Okay, if you said 7, that's fine, or 9, something, that's always fine because it's a guess. But you know it's closer to 53. All right, calibration. So the two numbers, we have 8 and 6. So that's 2 milliliters, and there's 10 spaces. So that's 0.2 per space, 0.2 milliliters per space. So this line here is 6, and then 6.2, 6.4, 6.6, 6.8. So it's between 6.6 and 6.8, and it's really close to 6.6. So we're going to stay at 6.6. Now, we can't have any more than that, okay, because we don't know exactly if it's 6.1, 6.0, 6.2. We just know it's 6.6. All right, some other pieces of equipment that you will use in the lab is a beaker. And this is basically just to hold cool down mixtures or heat mixtures up. The calibration is on the side. They either decrease or increase. And it has a lip, so it's easy to pour. Okay, so it's not measuring. You can use it for approximations. So for example, this one approximately is 225 milliliters. The second type is an Erlenmeyer, and it's also to hold or heat liquids, store them for temporary use. And you can use it to put a stopper on. So it's helped to store it overnight. You want to add these pictures to your notes. Either draw it yourself using a digital pen, or you can copy paste a picture from online. All right, graduated cylinders, you're always going to go from the bottom up. It goes up in values. The left side numbers, sometimes they have them on the left side, basically says how far you are to the empty, or how much you used already. But we're going to focus on how much you have in there, not how much you used. All right, so for accuracy, always use a graduate cylinder. and always use the smallest graduate you can without refilling it. So for example, if we need to measure 52 milliliters, you have to use a 100 milliliter graduate cylinder because the 50 is too small to measure 52. But if you need to use 48.5, then you can use the 50 graduated cylinder because it is less than the 50. All right, on your sheet, you're going to do calibration of these, of your notes. Okay, so you can pause it, make sure you check your work. But you need to show your work. So this is the first one. You should get 0.5, and the volume you should get is 23.1. Because this is halfway, so that's 22 and a half, and this is 23, so it's right above 23. Second calibration you should get is 1 milliliter per space, and that one's just above 90. So 90.2, 90.3, any of those numbers are good. And this one you should get 0.2 milliliters per space, and it's right in between 2 and 4, so you should have 12.3 milliliters. All right, so we're going to do a lab coming up. You're going to record the name, the size of the graduated cylinder, so 100, 25, 50, whatever, beaker or flask. You're going to show the calibration of the glassware. You got to show your work. Read the volume of the liquid, and then record it on your notes. Okay, so you write the instrument and the size. So a 25 milliliter graduated cylinder. You're going to show your calibration here, making sure you include units, and then the measured volume will be on the right side. Okay. All right, let me know if you have any questions, and we will do this lab coming up soon. Looks like this.